Hello guys, welcome back to MJ School of Mining and Geology. In today's lesson, we are dealing with the depositional structures confined to tidal regions. So basically these sedimentary structures called the Flaser bedding, the Wavy bedding, and the Lenticular bedding. So basically the reason these things are confined to the tidal regions is because a tidal region is a place that is between land and the sea, which gets to be covered with water when the tide goes or comes in, and then get to be exposed when the tide comes or goes out. So today's lesson, we are going to be dealing with these things, with these sedimentary structures. Please don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload new content. So basically, sedimentary structures are patterns and features in sedimentary rocks that form during or shortly after the deposition. So these structures tell geologists about how sediments were transported, deposited, and what conditions existed at the time, like ripples on the beach, mud cracks in a dry lake bed, or crossbeds in the desert sand dunes. So sedimentary structures, they tell us about the past environment. So for example, if we see the ripple marks that were, they are oscillating back and forth, you can tell that back in the days, the water was moving back and forth. All right. So basically, sedimentary structures, they tell us much about the past environment. Or for example, if you see the dinosaur's footprint, you can tell that this environment, it was rainy, and then we've got sand materials all over, and then which is why the dinosaur's footprint would be seen on that sand. So basically, like I said, the tidal flats, these are just this is just a place between land and sea, okay, which gets to be covered with water when the tide comes in, and then get to be exposed when the tide goes out. So that's what you call a tidal flat. So this is found in the coastal area, and then it's made up of mud, sand, and of course sometimes shells. Okay, and then these things, they are shaped by the constant rise and fall of the ocean. So tidal flats are basically common in, you can see now, this is the tidal flats. So these tidal flats are usually common in coastal areas and with gentle shorelines. And then also we expect these things in what we call estuaries, that is to say river mouths, where fresh and salt water they get to mix. And then also in the lagoons and bays, all right, are protected from strong waves. So basically, these tidal flats, okay, they form when the tide rises. When the tide rises, water will bring now in, or the water will come in with fine sediments like sand and mud. Then when the tide goes out, all right, or when the tide falls, the water drains away, then it will leave behind the layers of sediments, and then over time these layers build up, and then will create a flat muddy or sandstone facies. Okay. Or the sand surface. So basically, that's what the tidal flats are. Okay, so these tidal flats, because they are able to come in with fine sediments and also leave behind some muddy and sand surface, then these coming in and out of the tides, they would cause this kind of sedimentary structures, which are called Flaser, and the Wavy. Okay, so what are sedimentary structures? These are these sedimentary structures, or depositional structures, which are confined to tidal regions where sand and mud-sized fractions commonly mix. Okay, so because of when the tide rises, water will bring in fine sediments, and then when the tide goes out, then when the water drains away, it will leave behind layers of sediments. Okay, and then over time we're gonna have the layers that build up, which they are flat to muddy and and sandy. So this mixing of sand and mud-sized fractions would cause these three sedimentary structures known as the Flaser, the Wavy, and the Lenticular. These structures, they are very important because they help geologists to interpret past deformational conditions such as the tidal influences and changes in energy levels. So the Flaser bedding. So the Flaser bedding is thin layers of mud which alternate with sand formed in environments with fluctuating energy such as tidal flats. Okay, so basically what is happening here is we expecting to see in the Flaser bedding, we must see what you call cross-laminated sand which contain mud streaks. So if you can check here, we see the cross-laminated sand. We see the cross-laminated sand. We see the cross-laminated sand. Okay, so this cross-laminated sand would contain a mud streaks usually within the ripple troughs. So if we can check here, over here, this is the ripple troughs. These are the ripple troughs, and then in these ripple troughs, what we see is we see the mud streaks. We see the mud streaks within these ripple troughs. Okay, these are the what you call the mud streaks. Okay, even here you see the mud streaks. So if we have the cross-laminated sand which contains mud streaks, then these mud streaks are found within the ripple troughs. Then this what will be called a Flaser bedding, and then this is very common. This commonly forms in relatively high energy environment, what you call the sand flats in high energy environment, right? This is what you call the sand flats. But now on the other hand, the lenticular bedding, it's a mix of the sand and mud layers. So the mix of sand and mud layers forming a wavy pattern. So a wavy pattern, a mix of sand and mud layers forming a wavy pattern. You can tell they are in the form of waves. They are in the form of waves. These things, they are in the form of waves. They are in the form of waves. So these are the mixture of, this is the mixture of sand and mud layers forming a wavy pattern. This would indicate moderate energy conditions. So basically during the wavy bedding is where we have got thin ripple cross laminated. So we've got this thin ripple cross laminated sandstones, and then this sandstone will alternate with mud rock, and then, like I said, are commonly in environments that that would you expect the environment to alternate frequently from higher to lower energies. Okay, so these are what you call the mixed flats. So the mixed flats, which is why we are gonna be having the mixture of sand and mud layers now, which are in the form of the wavy patterns. So these are what you call the mixed flats. Then on the other hand, we've got the lenticular. We are having the isolated, we've got the isolated sand lenses. Okay, the reason we say it's a sand lens because of it's like an eye. Okay, it has got the eye shape. Okay, so isolated sand lenses in a muddy matrix. So we've got a lot of muddy matrix. Muddy matrix here. Remember, in the Flaser bedding, we've got just a streak, just a smaller portion of the mud. Then we've got dominant cross-laminated sand particles. But over here with the lenticular, we've got more of the mud, but now we've got the more of the mud in the form of matrix. Then the lenticular from the wet lens or the eye kind of vibe. Okay, so we've got the isolated sand lenses in this muddy matrix, which represent low energy environments like lagoons or tidal flats, because we expect mud to be formed in the calm environments. Okay, so lenticular bedding, it will be where you are having basically mud which dominates. Mud here, it must dominate. and then the cross-laminated sandstone occur in the form of lenses. They would occur in the form of lenses where the mud dominates. So these are commonly formed in relatively low environments because of you need calm environment for you to deposit these fine materials for fine material like mud particles. Okay. So basically, that is that these are the sedimentary structures that we expect to see, or which are confined with the tidal flats. That is to say, the land between or the place between the ocean, the place between the land and the sea, okay, which gets covered with water when the tide comes in, and then get to be exposed when the tide comes goes out. And like I said, you'd have a mixture of, you expect the mixture of the mud, sand, and a bit of shells, okay. So basically, these are the sedimentary structures that we expect to see, right? So without any further waste of time, I hope you understand these sedimentary structures that are confined with tidal flats. And if you enjoyed the session, you are more than welcome to like. And if you haven't yet subscribed to this channel, you are more than welcome to do so. But above all, please do not forget to hit the notification button below so that you get notified once we upload new content. And if you'd like us to cover other sedimentary structures, you are more than welcome to comment on the comment section below to know which sedimentary structures we can cover. Okay, I always like to say, until next time, cheers.